I believe that it's time to start with today's session on the INSEAD Tech Talk X series that we've been conducting within the context of digital at INSEAD, where we actually explore the new technologies, emerging technologies, established technologies, not just for the sake of the technology, but their impact on business, their impact on society, and impact on their ability of creating value. Hello again, my name is Enver Yücesan. I'm a professor of operations management at INSEAD based in our Fontainebleau campus, and I'm really happy to host you today and to actually lead the discussion on an important topic that we will be covering in a minute. So the topic today is the so-called hive minds and digital twins. And what we want to do is we want to use this framework to promote smarter strategy for business leaders. Now, the topic is a bit mysterious, so let me try to unpack that for us very quickly. Let me start from the end of it. Let me talk about digital twins first. So what is a digital twin, to make sure that we bring everyone to the same page? Well, a digital twin actually is a virtual information construct that mimics both the context, the behavior, as well as the structure of a physical system. And that physical system could be an engineered system, like a jet engine or a production facility. A natural system, it could be a field where you're actually growing corn, or it could be a social system or an organizational system, like a board of an organization. And what we basically try to do with this is that we dynamically update this virtual construct with real-time data from the physical twin, and then if necessary, do the quick analysis of what's going on in the physical system by using the capabilities of the digital twin, and then feed back those recommendations back to the physical system so that its operations can be improved. Now, there is a growing range of opportunities where digital twins are being implemented. For example, one idea is to ensure that you have information continuity as you go from one version of a system to the next one. Or for the more immediate applications, you can focus on real-time monitoring of the physical system. For example, if this is indeed a manufacturing system, you will be monitoring the state of the system so that you can do interventions in a state-based or condition-based fashion so that the operations of the real system would never be disrupted. In fact, in a lot of the cases, in an increasing fashion, a lot of the organizations would like to have some sort of a virtual commissioning based on the digital twin before they turn on the physical system. Now, what differentiates a digital twin from the traditional, for example, simulation systems is that there is a continuous real-time information flow between the two systems. In other words, the physical system provides the digital twin real-time online information about the operating conditions. And then in return, based on some sort of an analysis, the digital twin can actually feed back recommendations to the real system with no human intervention in between. So as a result, the information that we get from the real system would actually enable us to fine-tune the digital twin, and the recommendations that we get from the digital twin would actually help us improve the operations of the real physical system. Now, this is where artificial intelligence comes in. We've been using very, very successfully neural networks, machine learning applications in improving the use of information in both directions, in the sense that when we use machine learning or neural networks, that actually enables us to fine-tune our models, to make our models a lot more realistic, a lot more, with higher fidelity with respect to the physical system. And in return, we also use artificial intelligence, machine learning, or deep neural networks to be able to analyze the data in a predictive fashion so that we can have, better recommendations for the operations of the real system. Now, the issue so far has been the fact that this intervention by AI, this contribution by AI, has been pretty much limited to what I would refer to as structured tasks. For example, in a manufacturing environment, we'd be looking at maintenance issues, predictive maintenance issues, or condition-based maintenance issues, so that by collecting the data, we can assess what would happen over the next, say, 4 hours ahead of time to see whether or not an intervention is necessary. Or in other applications, for example, such as fraud detection, again, we could use machine learning, we could use some of these neural network applications to try to identify some iffy cases so that the physical system can take countermeasures. But these are all quite structured types of tasks in the sense that there is a standard operating procedure, there is indeed a desired outcome, and success can be evaluated in a very objective type of a fashion. But then at the other end of the spectrum, there are long-term, more complex tasks. For example, strategic planning is one such task, or decisions on new acquisitions or new market entry. Here, the standard operating procedures are lacking. There might be different definitions of success. There might be different outcomes that might be equally successful. So in those types of applications, the use of traditional machine learning algorithms or neural networks have been less successful until recently with the introduction of large language models. Now, a large language model basically is nothing but a word prediction algorithm, but they've been actually applied to a lot of different domains with a lot of success. They graduated from law school, they defended very successfully their theses, they qualified, they gave their qualifying exams with flying colors in a lot of doctoral programs. So as a result, we were thinking that, my God, these LLMs will actually give us the opportunity to expand the limits of our bounded rationality or the bounded rationality of decision makers that actually have to tackle these complex, less structured problems. But then we also have a worry about these LLMs in the sense that, given the fact that they're actually word prediction algorithms, would their capacity to create forward-looking theories be up to par? Given the fact that they had been trained on past data, we were thinking whether or not they would simply be reproducing conventional or already widely accepted ideas. And in other words, would they actually fall short of new and innovative ideas? And ultimately, we said, well, they've also been trained by using, general data, which means that would they be able to actually provide customized, targeted types of recommendations for specific organizations, for specific firms. So we basically kind of hesitating between the potential of these LLMs versus this idea of, well, how do we go about dealing with these shortcomings? And this is where the first part of the title comes in, which is the hive mind. And to be able to actually discuss, to be able to first introduce what that concept is and how that concept would actually enable us to indeed address some of the shortcomings of LLMs, I'm very happy to introduce to you our expert on this, a great colleague, Hamza Mudassir. Let me quickly introduce Hamza because if I were to talk about his uh, achievements, we're going to take the entire hour, but I'm going to just say a few words about what he has been doing. Hamza was a lecturer actually at in the strategy and policy department at the Judge Business School at Cambridge University, and at the same time, he was also the co-founder and the CEO of the startup Strategize.inc. Now, this is an environment that moves so fast that Hamza recently basically took a leave of absence from academia so that he can indeed dedicate 100% of his time to this extremely exciting and extremely fast-moving type of an environment. And this is the reason why we will actually be talking to him about how one can actually deploy these LLMs in a much, much more intelligent fashion so that we can indeed expand the limits of our bounded rationality so that we can address some of these complex issues. So, Hamza, thank you so much for being here with us today. And let me first ask the most fundamental question, this idea of hive mind. Can you tell us what it is? Can you actually define what it means for us?
First of all, thank you so much for having me, and very excited to be speaking to you, Anwar. And taking a step back, hive mind is not a term that I alone came up with. We had three other co-authors. One is my co-founder, Dr. Uwais Attar, who has a PhD in natural language processing and is sort of a proper LLM engineer. And then we had Professor Imran Saqib of Manchester University, who basically helped design the humanity side of our experiment. And then we had Meghana, who was doing her summer IP with us and helped us build the experiment for strategy. So taking a step back, Hive Mind, we stole the name from science fiction, and the reason why we stole the name from science fiction, if you remember Star Trek and all those others, there are always these cyborgs or these aliens that appear to be appear to be independent but are linked together in their minds to achieve a certain objective. That means that they are able to manage independent decisions, but all of those independent decisions are are in favor of a big universal goal. In the case of Star Trek, it's probably the elimination of species. But jokes aside, that's what Hive Mind is. Is this that each unit can behave independently and might appear chaotic if you're looking at it individually, but when you look at it all together, they are all headed in the same direction, if that helps. So it's based out of science fiction. So with that in mind, we thought we sat down and we thought about how do how do senior managers or how do great strategists actually make strategies. So bless McKinsey, BCG, they have their ways of doing things, but the Apples and the Microsofts and sort of those ingenious kind of strategies that we now take as gospel did not really just come from framework foundations. They actually come from a process of activity, and the activity is this: that you have three, four sort of really tuned in people who have different viewpoints about whatever decision needs to be taken, but ultimately they might even argue with each other, but they ultimately want what is best for the company or the shareholder or whoever the stakeholder is. So we thought about it and we said, okay, wait a second. We've been trying to get these LLMs um, to do frameworks and to do all of those things, but the real gem, the real novelty comes from arguing and then coming to a common place that makes sense to all the different perspectives. So our hive mind is what we did. We took four LLMs and gave them very discrete personalities, along with very discrete state-of-the-art models powering them. So they all belong to different vendors. And then we gave them a topic to solve, a strategy question, an HR question, and then we told them to argue and come back with a consensus after, say, 50 turns. And so they all pretended to be human. They all argued with each other, but ultimately they managed to collaborate and come back with novel answers. So that was the hive mind. The idea that you have these multiple agents that might appear chaotic at an individual level, but on a whole, they all are going in the right direction.
So Hamza, if I can actually clarify, so treat me as a 7-year-old who's a novice to this amazing world of technology. So basically, we have if I may call it, a complex adaptive system where each element, each member brings its own strength to the table.
Yes.
If I can bring this back to the analog world, you're basically putting a team together whereby each member has his or her own strength. And the idea is that by contributing that piece of the puzzle, ultimately, we want to move to a common goal of maximizing some stakeholder objective at the end of the day. Now, one thing that you said kind of caught my attention. You basically said, well, we gave each of these LLMs some sort of a personality.
Yes.
Now, in the analog world, this is an imperfect exercise because I mean, there's a huge literature on how to build teams. You go through, I don't know, Myers-Briggs types of types.
Yes.
You try to select them, carefully so that they complement one another. You avoid some sort of, group decision bias, pitfalls. How do you give a personality to an LLM? How do you actually make sure that on the one side, you take advantage of the individual strength, but on the other side, you don't create this echo chamber.
It's such a good question, right? So a hive mind is only useful um, if they at least spend the first 20-30% of their time arguing, because the one of the utilities of hive minds, which is an LLM arguing with another LLM to get to a good answer, is effectively it's taking on the role of the user. So as a user, you basically, when you're talking to Chat GPT, you are giving it feedback. It's a iterative system. It comes back with feedback, and you're making that loop happen. And that's why, for some people, they produce AI slop, and for some people, they produce an incredible sort of insights, are able to be very productive. And so, a lot of an LLM's capabilities are based on its ability to be challenged. What we have effectively done is that we've removed the challenging part from the um, human to the LLM. So the LLM, or first of all, we call this the inception layer. The first thing we do is we trick the LLMs, all four of them, to believe that all the other three they are talking to are actually humans. So that was very, very important, because in a classical sort of swarm modes, you have AI that knows that it is working with AI. And for things like strategy, or things that deal with more ambiguous topics like strategy, workplace ethics, organizational behavior, um, you want it to think that it is surrounded by humans. So that's the first thing we did. We effectively do an inception in their mind that deep inside they think they're dealing with other people. So that's one. The second thing we do is this, that even we ourselves don't uh, 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 create a prompt of a personality. We basically give a state of the art model the problem that it needs to solve, and it has to be a big chunky problem. You don't want to give it 2 plus 2, it's a waste of tokens. But if you give it a big chunky problem like audit these 10,000 documents for financial errors, or do sort of a classic McKinsey type strategy huddle, things like that, with chunky problems. We actually do not get the human to write it. First, a very big state of the art LLM thinks about how the problem will be solved, and it then creates synthetic personas appropriate to come to the right conclusions through the process of argumentation and consolidation. And it basically creates that inception layer for these four agents which are sitting blank. So we basically, the mother agent basically injects the personality. So that's that's number three, that it basically, even the personalities are simulated for the purpose of achieving a good output. But also, last but not the least, is something that we do, and we think it's useful, but for other people it's up to them whether they want to do it or not. We also give values around creativity, which is a technical value, which is called temperature. So depending on how repeatable you want this to be, you can dial the temperature down, and it will always produce insights that, your confidence interval goes up. It will keep on doing the same thing over and over again, but you put up the flame, and the electrons then collide a lot more, and more novel stuff comes out. So this is how we are basically simulating an expert with a bias and an opinion regarding a certain topic, when we deal with it at both the semantic level as well as the technical level. I'm happy to filter this down into
Right.
very simple words if you feel I'm getting too dense.
No, this is good. This is very good because I think we're going to talk about the two cases that you tested this thing out. But before I go into that, let me ask the scary question in terms of the infrastructure requirements, because I know that it's very exciting in terms of the applications, but uh, what do I need to be able to actually deploy such a capability? Because my first takeaway from what you're saying right now is that if I want to address these complex issues, uh, relying on a single LLM is actually a dangerous path. It has to be a group of agents, and I have to actually set the stage carefully so that I don't create this echo chamber. So before we look in detail at the examples, at the use cases, What is the technical requirement, the technical, I guess, foundation that needs to be in place before I can start harvesting the fruits of this effort?
This is a really good question, and I promised my co-founder that I will not do a sort of cheap cross-selling. So I will not say come to us, but I think on there are two ways in which you can switch this on, and both of them are actually quite fast and quite cheap. So the first one is a no-code tool called Langflow. It was recently bought by
Mm-hmm.
IBM, and it allows you to make allows you to use with zero code, create these long strings of arguments, and then you just press the play button and off it goes. So a lot of your time is actually spent about thinking about what parameters to put into the simulation versus if the simulation is possible. You can literally go today, go to Langflow. It's probably not more than a day's worth of sort of experimentation for an MBA type to get really good at it. And then you can create these, they won't be as uh, immaculately articulated as a more professional solution, but it'll
Mm-hmm.
get you there. And you will see the value of it almost immediately. So if anyone wants to do the stuff that we are talking about over here, and you do not know programming, just go to langflow.org, download their product, and it's like Scratch for adults. So that's one way of doing it. But for the engineers in the room, um, there are so many frameworks out there right now that you can even get an LLM to program this for you. So, for example, things like LangGraph,
Mm-hmm.
and Crew AI, very straightforward frameworks. If you are even a little bit technical and you don't want to use Langflow, then you can get your engineers to get an LLM to build something at least basic. Of course, what we built is meant for production environment. We provide these solutions to Fortune 500, so our sort of our level of rigor is higher, but it does not mean that you have to wait for say 2 years to get this in your hand. You probably need to, if you're really committed, probably like no more than a couple of weeks.
I see. That's encouraging. So let's have a look at the two benchmark study that you actually have carried out. I guess one of them was an HR case, a harassment case inside an
Yes.
organization, and then the other one was a strategy case, a brewery, turnaround going, I guess, to international markets, so to speak. Uh, can you tell us in terms of, what was the experimental setup? Let's talk about that first, and then let's talk about some of the outcomes, some of the, I guess, comparisons that you have done and, surprising results, non-surprising results. Can you tell us about those two benchmarks, please?
Yeah, absolutely. So, sort of in a classic MBA way, we are doing a 2 by 2 matrix, and the 2 by 2 matrix that we had little time, and so but we needed to do the benchmark. One uh, axis is experience, like work, life experience, work experience.
Mhm.
So we did two clusters. One we did with sort of MBA students who had like 5-6 years of experience, and sort of your classic high potential, very clever, driven, but do not have say 10 years of experience. So that's the one lot. And the second lot was people at chief HR level, people at director HR level who have at least 10 years of experience in that area across different geographies. So we wanted to think about the variables not in terms of discrete units that we need to change, but to say, okay, how much life experience do these experts have? I think it's a worthwhile question to sort of put it there. And the more sort of horizontal axis was at the simplest end, it was a generic problem, and at the more complex end, it is more human, more values oriented, more geographic centric. Things that work, for example, in the UAE might not work in the UK, for example, when it comes to HR policies or how we treat people that we work with. There are very different ways of doing it. There's not one or wrong, but there's not one which is right or wrong. But culture is a thing, and we need to account
Mhm.
for it. If we are simulating decisions that would directly impact humans. So the experiment was basically, then we made two groups, four each, and we had an independent moderator. So the MBAs got the strategy case, which was very generic, but a difficult case. I mean,
Mm-hmm.
it wasn't an easy case. And the second one was the HR case about, it was a fake case, but written in a real way, about this employee who felt harassed, versus her manager, who was a superstar in the company, who holds 40% revenue responsibility. So not someone you can take too lightly. And so we said, okay, the ones with a lot of life experience, let's give them the tricky human bits, and the ones
Mm-hmm.
with lesser life experience, but sort of we know that the cognitive elements are there, the underlying intelligence is there. They're doing their MBA, and they've gotten into good school, so they're smart. So can we give them a generic problem and see if smart versus smart would win or not? So these were the humans, and then what we did was that we created two hive minds, and gave them the same case study, and gave some instruction on making sure that the profile types were covered in the simulated one. And then we ran the human advisory group, obviously only once. You can't run it so
Mm-hmm.
many
That's
times.
yeah.
But the other one, we just we went to town. We ran it a lot of times, at different settings, trying to understand where does it spout nonsense, where is it being brilliant. And the results were, as you can imagine, quite interesting.
Actually, let me, no, thanks for describing the setup. In terms of the comparison, what were the criteria that you have used to identify similarities, divergence, quality of the recommendations? Uh,
That's a really good question, right? So one part of it is this, that we had a couple of PhDs in the group. So like Oais, Imran, both, Oais has a PhD in NLP, Imran has a PhD in human resource management, and both are practitioners as well. And so one part of it was, obviously, our our impression of it. I used to teach strategy, so I look at strategy outputs, I'm like, okay, yeah, this largely makes sense. So one part is the subjective side, but we thought that it would not look good if everything was subjective. So basically, we got the computer scientists in the room, to use natural language processing algorithms to be able to measure things like collaboration, things like competition, things like how hostile the other person was. And we also, other than the natural language processing of the interaction dynamics, we also took all the ideas that were generated by the humans and all the collective ideas that were generated by uh, the hive mind large language models, and then we did a benchmark as to find out how novel they were by basically getting other AIs to scan the internet and all the scholarly work that exists today in the world, and to see how novel it was. So we gave a rating of novelty. And as you I mean, you definitely know, novelty isn't everything. There is also practicality, how useful it is, right? I could say, look, I want to have a purple elephant, and that will be really novel. And where you will say, who's going to buy a purple elephant? Like, that's a ridiculous idea, and the elephant will be in pain because you're painting it purple. So novelty is not one thing; it's also practicality of it. And so we did the novelty, and then the human experts ranked it on practicality. And so the data that I had shared with you, had that ranking in place, and it allowed you to see how novel were the humans and how novel were the LLMs.
mhm. I see. Now, I guess you could run the experiment only once with the human group because
Yeah,
of costs, constraints, etc. But you were saying that you replicated the LLM, the Hive Mind a
yeah,
couple times. Um, how long did it take to, I mean, can one talk about convergence that ultimately there is,
yes.
so how many iterations, how many replications does it take until you say, okay, well, the algorithm has converged, the group has finally arrived at a recommendation. Are there any guidelines for judging this?
Absolutely. So the one thing that quite a few people who don't work with LLMs at an engineering level is that ultimately it's a Monte Carlo. It's a roll of
Mm-hmm.
the dice.
Mm-hmm.
So the temperature is how hard you want the dice to roll. So, for example, if we do a temperature of nearly zero or 1 0 being it is not being creative, it will almost always produce the same tokens. It will almost always converge. So then the question comes in is that if you want to get it to be more creative, i.e., choose unusual next word predictors, which is basically what it
Yes.
is,
Yes.
what then you need to then run the experiment several times over. We usually look at 30. You can run it as a batch, and the
Mm-hmm.
batch can be allocated as well. So at least again, we because we deal at a production level, we have those systems in place. So if you're running something at a temperature of 1, I would say run it at least 30 times and then get the master AI to just consume all the outputs and come back with the sort of
Yes.
congregation of ideas. The reason you would, and it costs more money, obviously, but because of tokens and compute, but it is incredibly important that you do play with high temperature settings, which are low probability outcomes, because that's where the novelty comes.
Absolutely. But I guess, I mean, thank you. You had shared some numbers with me. For instance, when you were looking at the real analog human experiments, we were looking at things like 1.5 of or 2 weeks of setup time, and then the session
Yes,
durations are about 45 to 60 minutes, versus the setup time for the LLMs was less than a minute, and then
yes,
each session lasted less than 10 minutes. So indeed, it is indeed feasible to run 30 or more replications,
exactly,
especially if you want to generate these, I guess, long tail types of outcomes
exactly,
in
exactly.
these Monte Carlo experiments. Now, let's go back to the outcomes, actually. Let's start with, I guess, relatively easier, the strategy case, this brewery turning around, going abroad. Um, in terms of observations, in terms of the outcomes, can you compare the recommendations of the human group with the recommendations of the, agentic AI? Uh, you know, Differences, divergences, or commonalities?
Absolutely. So I think there were. It's really hard to say what is good or bad when it comes to these creative outputs. So I can only tell the differences.
Sure.
I think the one thing that I would say was the big difference uh, between the human participants in the case of strategy and um, the LLM uh, was simply that time is a very different constraint for LLMs. So, for example, for humans, we had to have a 45-minute cutoff. So there's only so much that three or four people can say physically in 45 minutes. So if you were to imagine that if you were to benchmark number of words to be the equivalent of volume of output, useful or otherwise, if you park that
Hmm.
aside,
Hmm.
the LLMs were able to, in 10 minutes, were able to produce 4 times the output that the humans could produce in 45 minutes because they're not time bound, they're compute bound. So when we give you a powerful model, it will produce more words and more tokens than a weak model. And then if you dial up the temperature and you really incentivize it to dig in deep, then it will just produce more output. So I think output for output, uh, it was more complete than the MBAs.
Hmm.
So if I was a client and I only had 45 minutes to solve a problem that was strategic, difficult, and I really wanted to get to the nub of it and to come back with a good decision, I wouldn't go to a McKinsey with MBAs. I would just run this because in 10 minutes time it will tell me enough that I can go in with my eyes open. Ultimately, we think of AI not as a decision maker, but a decision enabler. It's a sandbox. It's basically a bunch
Hmm.
of toys for executives. We should not treat it more than that. And you can learn a lot from toys and from and putting sand in your mouth, but as long as you're in the sandbox. But for humans, 45 minutes is a long time. And so if I would say like for like, I would imagine that it would have, if the MBAs were sort of powering through it and were sort of doing all the math and everything, it would have probably taken them a couple of days to get to the same level of output. So
Hmm.
in both cases, the output was far more for LLMs. They just chat more. When they are more intelligent, they talk more.
But in
Um,
terms of implementability, in terms of practicality, were they up to
Very
par?
practical, and that's
Hmm.
the so. So, for example, humans couldn't really get to the point where they could open up an Excel sheet and model. This thing had done it had
Yes.
done like 1,000 Monte Carlos by the time it got to the answer. So I would say that unlike traditional LLMs, our agents have things like tools. We give them computers. They can write script. They can write code, and from that code, they can learn back. And so in terms of usability, the LLM agents were, I would, because they had done the whole thing, they were more practical because they didn't have to stop midway. They had produced all the artifacts that you need for a management presentation, so it was able to produce some nice McKinsey looking slides. It also did like it even gave us, we didn't even ask it, it gave us a mathematical model on sort of how to measure the supply chain impacts. It had also, on an emergent level, because the MBAs did not get the time to get to that point, but the LLMs
Mhm.
had already shot ahead, that we had not asked them a question about operations management and the
Mm.
supply chain. We had not asked either of them. We did not. We wanted to focus on corporate strategy, but at some point, the four LLMs came to the agreement that, wait a second, strategy without execution, i.e., supply chain, is a bad idea. So they basically, once they were done with everything, were not producing more noise. They moved on and they caught even our
Mm.
own blind spot, that we were so focused on the classical,
I
do
see.
this in a framework, that was like, okay, we've done it. But you did not ask us about supply chain. We think it's a really important thing. So here we've solved supply chain as well. Now, humans will do that as well if they have the time. So
Mm.
I would say that on very generic problems that are only about brute force sort of intelligence and computation on sort of standard frameworks, theory, whatnot, and it does not have a lot of variance in terms of culture, geography, speciality, places that the training data cannot touch. You're probably better off running a Hive Mind first.
I see. How about the other case, the HR case with the harassment, which is a lot more
Yes.
complex, a lot more human, a lot more sensitive? How was the performance there? How do you compare it?
So the experts who had spent decades in those geographies and were nationals of those geographies were superior. And they were superior not on. So we had a chief HR officer from the UK. So it was able to predict the UK chief HR officer quite well, because it is so heavily trained. Almost all your corpus of knowledge on modern HR is in English. It was trained on it
Hmm.
and it knew all the rules. It basically was neck to neck. But we also then had three other HR professionals, one from Pakistan, one from the Middle East, other from Bangladesh. And their view and what they were bringing up were sort of these missed gaps that the LLM could not have known in any way,
Mm.
because they're so idiosyncratic to that geography, like Pakistan. So in Pakistan, we give a good example of it in our paper. We said, look, in Pakistan there is a concept of a SAT company. A SAT is sort of like, very top down. It has a negative connotation to it. And the HR director from Pakistan said it like this. The first two sentences were, if this is a SAT
Okay.
company, we have to do these things. The LLM just did not even know what it was. And one and the reason that this was a really big blind spot was that with everything else, we could see that the argument was deriving to the right conclusion.
I see.
So that the derivation of reasoning by challenging each other will bring you to the right answer. But if Seth culture is something which is so idiosyncratic to Pakistan that even people in India do not know about it, but every Pakistani corporate worker knows about it because it's our source of fear, the LLM could not derive to that point. So training data beyond Western organizations, Western cultures, is neither here nor there. So for sort of purely intellectual stuff where you need to sort of derive an equation out, that is relatively straightforward now. Figuring out the nuance which is idiosyncratic to a city, to a town, to a to a state in a country which is not heavily digitized, you will probably get wrong answers.
I see. So then, let's see. In terms of my takeaways here, uh, do not fire your chief strategy officer. Do not fire your chief HR officer, because as you were saying, this is a sandbox, this is an idea generator, this is a scenario generator, but ultimately the final decision has to rest with the decision maker himself or herself.
Exactly.
And the second point also brings back the training part. That a lot of it is still Anglo-Saxon, a lot of it in English, but so this idea of regionalization, taking
Yes.
into consideration the cultural aspects, is something that we have to still work, have quite a bit of work to do.
Absolutely. I think I met this the gentleman reporter from Financial Times a couple of weeks ago at the Judge, and we were talking about this experiment, and one of the questions, his name is Andrew Jack, and one of the
Hmm.
questions he asked me was, so what is the future of MBAs? What is the future of managers? And I think the answer to that was that the future is actually quite secure as long as you are able to manage this thing that can do maybe 10 times your output, and maybe equivalent level in terms of coming up with new ideas. But it is you who needs to harness it. It is not going to get to the right answer on its own, and it is still, despite all of the supercomputation capabilities we have, I would never give a Hive Mind complete control over our very small startup, simply because I know that its reason for existence is to help me perform better, is to help me identify my blind spots, but not to take
Hmm.
decisions on my behalf. So an MBA who knows how to, and I myself am an MBA, an MBA who knows how to deal with artificial superintelligence, general intelligence, and understands the idiosyncratic changes that they need to keep in mind, whether it is their company, whether it's their market, whether it's their product. You need to be as an MBA, you need to be the caretaker of the idiosyncrasies, because the agents will never get that. But without those idiosyncrasies, you will end up with slop. So one without the other is not equal. Both of them are
So
not good enough on their own now.
I see, I see. So we're looking for augmentation rather than replacing one
Yes,
agent
you
processing
can't
everyone.
replace humans. Not in a market that caters to humans. Who do we put
That's
in jail if
mhm.
something goes wrong, right? I mean, I don't want to
Oh,
put mine in jail.
that's a whole different conversation that would probably require more than an hour to actually sort things out. Um, were there any surprising outcomes, stuff that you didn't expect, and then it popped up like this?
So I think I thought that at high temperatures or sort of high creativity levels, we would be in a situation where we get a lot of garbage, i.e., the agents are simply doing permutation combinations. It's a pattern recognition
Hmm.
machine, so
Hmm.
it's
Yes,
combining patterns and coming back with it. But when we did the benchmarks around novelty and practicality, on balance, the agent's arguments were able to pre-filter out the garbage. So because we had other agents arguing with the agent coming with the idea in that turn, because of their argumentation, the garbage was getting pushed down in priority in the conversation, and only the winning ideas were being pushed up. So ultimately, when we looked at what were the winning ideas, the thing that really surprised us was that they were actually quite good. And the reason was not because one LLM is this incredible LLM that we all really need to follow, but it was the interaction of the LLMs that reduced the garbage
I
at
see.
source.
Okay. Now, at this point, I'm looking at the Q&As. One of the questions that Alain Dardi asked actually is quite relevant to the last point that you made here. Alain says the following. He says, Perplexity is supposed to blend several LLMs. How is your model different? Human impersonation and various temperatures, or is there something else?
So the difference when we say Perplexity has various LLMs, that is a single model that you can run for a single unit of work, and you can keep on changing it. I'm not saying we don't build models, we build harnesses around those models, which is different from. So R is different than Perplexity because we have four models running in parallel at the same time, solving different aspects of the same problem and counter checking each other. And so that's why they're a hive mind. They're running all in. Basically, it's four pipes running together. If you think in terms of CPUs, it's like having four CPUs that are aware of each other and can work together versus
Mhm.
one CPU that is working in serial. And because there is no challenging, the output of a single model just doing things on its own is particularly dependent on its training or the human being the counterweight. But when you use four different models from four different vendors with four different training sets with different biases and sort of different tools, what the chaos produces the filter. And so I would say that if you were to ask Perplexity the kind of questions that we asked our human focus groups and our hive mind, it would not be able to give you that many tokens because it just doesn't. It does not have enough thoughts for one agent, and the chances are that it will be too comfortable in what it is recommended to you. uh, and so the quality of output, the novelty is a lot more if you're doing a hive mind approach. You don't have to use our solution. Honestly, use whatever. But if you have orchestrated it correctly for a certain kind of question, Perplexity won't be able to answer it. So you do need this to literally go away for an hour or 2 hours or 3 hours or 4 hours, argue it out, come back with a full thing. No LLM can do that right now.
I see. Here's another one that's actually follows up nicely. This is from an anonymous attendee. He or she says, could AI boardrooms become a new source of competitive advantage, and what would early adopters gain? And the follow-up to that is that how could multi-agent AI debates combined with digital twins transform the way strategic decisions are made and validated?
Very good, very good question. Let me answer the first one about a virtual board with an. So
Hmm.
I'm under like a ton of NDAs, so I of course cannot give
Yes.
names, but we are working with a huge technology company on the Nasdaq, and their CEO was presenting their forward-looking plans to analysts. And before doing that, they asked us to simulate what the analysts would think about it. And we basically, our agents went online, looked at sort of the major analysts who are covering that company, went to LinkedIn, looked at their profile, looked at all their articles and interviews, and created a hypothetical of those, and it was quite useful. I cannot give very very specific things because then you would find out who they were. But it was quite. They changed their strategy based on the simulation of an analyst response, and across the board, their executive team, there are eight of them, they all agreed that it probably got it right because deep inside they were they all knew that the CEO was going to do something that they didn't agree with. So the AI hive mind was also a safe place for them to talk about disagreement. So I think so that's one. So there are already companies out there that are getting utility in terms of market cap if they were to use it. The second question about was that about the comparative advantage? I
Hmm.
think so. I think every executive at some point needs um, to have these mathematical models that can help them get out of their blind zone, right? And that is where the utility is. The comparative advantage comes out of the human performing better, not because an LLM is performing better than the human. So for these kind of things, absolutely. I always when I used to teach exec ed, people used to ask very similar questions like, where do we fit in the world of AI? And I tell them that in Iron Man, the Marvel superhero movie, Tony Stark on his own cannot stop the end of the world, and Iron Man suit itself is just hollow. It is the combination of the two that makes sort of Iron Man, right? So this is the way when we build our products, we actually, funnily enough, also ask ourselves that would Tony Stark use this, or is this natural enough? And that's how I think the future is going to be. But obviously, God knows.
Right. I mean, you're one of the people actually who are trying to shape it, so that's quite neat. There was a part C of it, the connection with the digital twins. If I may,
Yes,
let me just
of course.
jump onto that. One of the I guess key value potential of digital twins is their ability to do the analysis and generate suggestions. But the time to actually run the analysis and generate suggestions is now becoming a fraction of a second. I mean, think
Exactly.
of a self-driving car, and then you have a condition you have to decide on whether to hit the brakes or to turn. So here, within a fraction of a second, you have to run the algorithm and come up with a decision. There, AI comes in. There, our traditional algorithms, regardless of, how efficient they are,
Exactly.
they're requiring, 5 seconds, which is too late. That's where we get, the value of these tools to be able to indeed, as you were saying, come up even with, ability to generate situational decisions to avert the situation. So that's, I think, where the value would come in. Now, if I may, coming back to the how the system works, maybe a bit on the technical side, Mutu has a question saying that so strategize follows more of a parallel real-time interactions rather than series real-time interactions between the agents to be able to get that type of a performance. Is that the idea?
I would say that we are more emergent. So we do give, so depending on how you set it up, we do sometimes make one of the agents the boss if it's a very hands-on get stuff done kind of work, like an audit or fraud detection, things sort of more you need very quick answers in a variety of ways. In that situation, it's emergent. So the boss decides whether to do parallel calls, whether to do serial calls, whether to yeah. So we say that the we have given the optionality of a round robin. A round robin is everybody takes turns to
Hmm.
speak. But we also allow, if you have a boss or a moderator, we allow them to sort of break the round robin as well. So the hive basically moves where it sees the value. Um, and then so they're self-organizing in that way. So they self-organize and they can either go round robin or they can sort of uh, collapse and create another form of interrogation. It's very interesting because when you're seeing it in real time, they do funny stuff. So to answer that question, we give it the options to do both, and sometimes it does surprising stuff.
I see. Coming back to the application side, then here's another question from an anonymous attendee. Could hive minds be a way to counter the current issue of limited diversity in AI development? For example, if you assign the hive minds very different backgrounds and personalities, or is it the core problem still rooted in the data that the models use?
I mean, a lot of it depends on what you are using it for. So I would say that, for example, if you have a strategy problem in a country like Germany, very well documented, high degrees of sort of training artifacts and whatnot, it doesn't matter what you put in the prompt, because ultimately the intuition is correct because of the training data. On the other hand, if you were to start putting in diversity without the training data, it's just hollow. It will be cliched. So to answer the question, I would say that this is a fantastic opportunity for sovereign AI. We do need countries to do their own training, and if we don't do it, the problem will remain. At least this is in our opinion, just given the tests that we have done. That, for example, if there is a country in Africa that is has similar low levels of training, I could prompt the living life out of the agent. It will
Mhm.
spout nonsense, which is what you don't want. So we still have some ways to go.
I see. Here's the tough question that I had in my mind as well, but Irina asked for this. Uh, this very interesting and has a huge potential, says Irina. However, what is the impact to environment from deploying such models? And again, we read these statistics. For example, if we continue with the current trajectory with these LLMs, ultimately we're going to be needing more electricity than the entire country of Denmark. Um,
Yes.
a single prompt in ChatGPT uses about what 50 centiliters of water for cooling all these server farms, etc. So how do we avoid the tragedy of the commons in the sense that how do we actually, because it also starts from the rare earth materials in manufacturing these chips to running these data centers with the electricity, with cooling. How do we establish the balance?
So I would say that that's a very real problem. It's a very real question. You need more nuclear power plants. It's not going to be great for the environment. But I cannot really speak on behalf of the industry. What I can do is we can speak about how we handle this problem.
Please,
So
that'd be
at
great.
Strategize, we're effectively a bunch of nerds who got together and said, look, we need to do this and we need to do this right. And one of the things that we do is this, that we optimize for on-board GPUs, which means that if you have a Macintosh, an iMac, or an NVIDIA laptop or desktop, our solutions can run Hive Minds on local GPUs, which is effectively the same amount of energy as playing video games.
Mm-hmm.
And so in our case, we also had to do it because of privacy concerns. A lot of executives do not want their thoughts being streamed to OpenAI for very good reason. And so what we do is this, that we create what is known as a red box. In people who are not from the intelligence community in the UK, around 400 years ago, the Queen set up this concept of a red box in which the head of state is the only one who can access really, really secret documents, and they're in a little red box. And so we call it a red box. And in the red box, you can run all of these things, slightly lower fidelity, but you don't have to have a water chamber to run it. It can literally run with the same amount of electricity as it takes for a PlayStation 5. And that's how we are dealing with the problem. But for the entire industry, for humanity, you're absolutely right.
Yeah.
This is not sustainable.
Because we also had a question from another anonymous attendee from Japan, and basically saying that Japan's facing difficulties to charge such big power. So in
Yeah,
this situation, what's the priority for Japan? What's the best balance point between AI and humanity? So these are actually deeper questions. I'll take one last question here, and then we'll wrap it up because we are definitely getting out of time. Uh, Graham says, when will INSEAD launch the promised digital twins of the professors as teaching aids for alumni? Well, actually, I'm not a real professor. This is an avatar that's talking to you. No, joking aside, INSEAD actually is actively working in that domain in terms of being able to actually reach a much broader audience, but in an environmentally responsible fashion. So on that one, please stay tuned. My last question to you, Hamza. You have a cool paper coming up on that summarizes this experiment plus gives further details. Where is it being published? When is it coming out?
I mean, so we've got. So I can't. I the editor has to give me the timeline.
Oh,
But
I see.
what we are hoping is this, that we had shared with you all of the intrinsic information that came out of it. I think we are, over the next month, we will basically open up both access to sort of people like who are attending this conference. You can reach out to us over the next month, and we can actually give you access to play around with the R version of the Hive Mind. But we will be opening up all of the information and data that Professor Anwar has seen only so far over the next month. And we can share it with the INSEAD folks, and you should be able to be able to look at it in more detail.
Hamza, thank you very much for this very, very interesting session. So my take on this is that we need a group of LLMs to actually hash things out. However, the human decision maker has to still sit in the
Absolutely.
decision maker's seat and make the final call. It's just a tool that enriches I guess, the search space in a very
Exactly.
methodologically, structured way, so as to improve the quality of the final decision. Thank you so much for being here today. Thank you so much for actually doing the heavy lifting and undertaking these really, really interesting and impactful initiatives. We'll definitely be keeping an eye on you. And I would also like to thank all of our attendees to
Yes.
spend the time with us to listen to the cool work that Hamza is doing. And again, we'll have a recording of this. you will receive an email. And again, as Hamza generously offered, you should also feel free to pursue this further with him. And with that, I would also like to thank Sandra, who's been working behind the scenes to make sure that this delivery has been seamless. Thank you so much. Have a great day. And if you have, any feedback, positive, negative points of improvement, do not hesitate. We're only one email away. Thanks a lot, Hamza. Thank you,
Yeah.
everyone. Have a
Bye.
wonderful day.
Bye.